Okay, this is a very long example, but it encompasses so much what I call concepts, right? That if you can understand this example completely, I think you will have a good grasp and understanding of what this kinematics, right, using calculus is about. Okay, so let's just delve into example 4. So example 4 talks about a particle traveling a straight line. So at t seconds after passing a fixed point O, the velocity is given by v equals to t squared minus 10t plus 9. So first and foremost is an expression in terms of t for the distance of the particle from O at time t. So what we're going to do here is this. First part is still very manageable. If I know that my velocity is t squared minus 10t plus 9, so differentiating displacement gives you velocity, hence integrating velocity with respect to time will give you the displacement. So I get 1/3 t cubed minus 5t squared plus 9t plus my integration constant c1. Okay, so now how to get c1? Initially it passes through the fixed point O at t equals to 0. So that means that when t equals to 0, as the displacement s equals to 0, so 0 equals to 1/3 0 cubed minus 5, 0 square plus 9 times 0 plus c1. I find that my constant c1 is 0. Hence, the expression for the distance displacement is 1/3 t cubed minus 5t squared plus 9t. Now, the next portion here for part 2 is this. For part 2, they will speak about the values of t when the particle is at instantaneous rest. So if you remember, at instantaneous rest, velocity v is... So what we can say here is t squared minus 10t plus 9 is equals to 0. Simple factorization yields t minus 9, t minus 1 equals to 0. The two values are t equals to 1 or t equals to 9. So at both t equals to 1, instantaneous rest, the particle is turning to face the other direction or to travel in the other direction. T equals to 9, same thing, the particle turns again. So how you want to visualize this is basically this. So basically there's a point O, the particle is here. So it starts to travel. At 1 second, it stops, it U-turn, then it starts to travel backwards. T equals to 9 seconds, it will stop, it will U-turn, then it will travel again like this. Okay, so that is what is happening. So I start again. T equals to 0, then at t equals to 1, it will U-turn, it will stop, it will U-turn, go the other way. T equals to 9 seconds, it will stop, it will U-turn, it will start traveling to the other side again. Alright. So based on this idea that we have here, so the times that where it's at instantaneous rest is t equals to 1 and t equals to 9. These two numbers will come in quite importantly later, but now let's just do part 3. Part 3, this is an interesting question. We've not tackled something like this, okay, yet. So they actually tell you that the distance traveled in the third second. What is the third second? The third second means that, right, it starts at the second, okay, then second until the third second. So in this space of time between t equals to 2 and t equals to 3, this is what is defined as the third second. Okay, because first second, second second, 2.1, 2.2, 2.3 until 3, that is defined as a third second. So basically, what I'm trying to find is what's the displacement of the article at t equals to 2? What's the displacement of the particle at t equals to 3? And then I see what the distance actually is. Okay, so now at t equals to 2, my displacement, which you remember from the previous portion, let me just write it down for you, from the first part itself, the displacement is 1/3 t cubed minus 5t squared plus 9t. So at t equals to 2, what I have is, so my displacement in this case is 2/3 meters. Okay, now, so that means at t equals to 2, what happens here is this is 0. Let's imagine that this is 2/3 is maybe somewhere here. The particle, okay, at that point in time at t equals to 2, t equals to 2, correct? Okay, the particle is 2/3 meters away, okay, from the initial starting point O, like that. Okay, then remember that at what happens now is at t equals to 3 seconds. Okay, so what we'll do here is at t equals to 3, the displacement s is 1/3. Okay, what I'll have is -9. So where is -9? Okay, it's here, -9. That means the particle, okay, what happens to the particle at t equals to 2 seconds, okay, and at t equals to 9 seconds, the particle is somewhere here. So, what is the total distance it has traveled? Okay, so the first question that we need to ask, right, is has the particle turned, okay, during these 2 to 3 seconds? It has not. Okay, if you remember from the animation I did just now, t equals to 0, it starts to move. T equals to okay, t equals to 1, okay, it has t equals to 1, it will the u-turn one time. T equals to 9, it will u-turn another time. So the question now here is this: between 2 to 3 seconds, has the article turned? Okay, no, it is not. Okay, so how to visualize this is basically this. Okay, at t equals to 0, it starts moving. At t equals to 1, is maybe here. Then it starts to u-turn at t equals to 1. T equals to 2 is at this point here. T equals to 3, it still doesn't u-turn. When does it next u-turn again? At t equals to 9, because it's an instantaneous rest at t equals to 1 and t equals to 9. So at t equals to 1 is maybe somewhere here. T equals to 2 is at this point here, exactly 2/3 meters away from O, and t equals to 9 is somewhere here. At this point at -9 is just simply t equals to 3 seconds. So between these two timings, the second t equals to 2 and t equals to 3, the particle does not turn. So basically, what I can say is that the particle is moving this way, okay, from 2 to 3. So the total distance it traveled is this 2/3 plus this 9 meters. So 2/3 plus the 9 meters. If I can write this down, the total distance is equals to 2/3 plus 9. So the total distance traveled is 9 and 2/3 meters. Okay, part 4. The total distance traveled in the first 10 seconds. So I think it's best if we represent this using a diagram. So now, if you remember, okay, the particle will turn. When does it turn? At 1 and 9. So at 1 second, it will come here, it will u-turn, go all the way to 9 seconds, u-turn, then it will go back here again. Okay, I repeat one more time. First, it starts moving, 1 second u-turn, 9 second u-turn, then you start moving the other way already. So what we need to do is the critical junctures is at t, the critical junctures for us is t equals to 1, okay, and the other critical juncture is t equals to 9, because these are where the instantaneous rest occurs and the particle u-turns. So now at t equals to 1, the displacement, if you remember, our displacement was 1 over 3 t cubed minus 5 t squared plus 9t. So at t equals to 1, I calculate that my displacement is 4 and 1/3 meters. Then at t equals to 9, my displacement that I calculate, right, is negative 81 meters. finally, okay, at t equals to 10, all right, I need to know where the particle is. So at t equals to 10, my displacement, if I use this equation, my displacement is negative 76 and 2/3 meters. So basically, what happens here is this. My particle starts at t equals to 0, no displacement. It will travel for 1 second until here. It has traveled 4 and 1/3 meters. Then the particle will U-turn. So it's U-turn, okay, it will travel all the way back until somewhere here. This point here is the negative 81 meters. Okay, then what happens at negative 81? Particle will U-turn again. U-turn and travel until t equals to 10 seconds is negative 76 and 2/3. Okay, so here is where the confusion will lie. Okay, see. Okay, if you just focus a bit here, let me try to use a different color here. Okay, what I calculated was the displacement is negative 76 and 2/3. So where is this negative 76 and 2/3? Negative 76 and 2/3 is here. Negative 76 and 2/3. So the distance here will be a bit more, it's a bit more difficult to calculate here. So now each portion I will just label for you to see how I get all the figures here. First portion from here to here is 4 and 1/3. Then from here to here, okay, I just alternate colors, is 4 and 1/3. Then from this 4 and 1/3 all the way to this portion here, okay, from what I've seen on my graph itself, okay, on my diagram, this is 76 and 2/3. Now, what I can do here is, the next portion here is the more difficult part. This portion here, what I can do here is, I can take the 81 minus 76 and 2/3. So, let me get a calculator, never mind. 81 minus 76 and 2/3. Just let me get my calculator first. Okay, so I get 81 minus 76 and 2/3. Okay, I get 4 and 1/3. So this distance that I have outlined over there for you, it will be, here is 4 and 1/3. Then this distance here, again, will be 4 and 1/3. Okay. So what we have here is this, okay, in total, okay, what I have here is I've already recorded down all the different portions here already. So what I can have is the total distance traveled is equals to, first, we will begin with the 4 and 1/3 plus the next 4 and 1/3. So I've used these two already. Then plus the 76 and 2/3 plus the next 4 and 1/3 plus the next 4 and 1/3. So if everything it works out, okay, so 76 and 2/3, what I'll get is the total distance traveled is 94 meters. Okay, this is a more, as I said, a more difficult example, but if you can get this example, I think you have more or less caught the idea of what kinematics is about. Right? So now please try 4. Okay, try 4 has 4 parts, is similar to what we have done. And then I'll give you the answers in a short bit. Okay, for part 1, okay, find expression for the particle in terms of t for the displacement. So once again, the main concept here is you integrate velocity with respect to t, you get the displacement. So don't forget our good friend, the integration constant. So we know that initially when t is 0, the displacement is 0. So the integration constant c is 0. So displacement is given by this formula, by this equation, s equals to negative 10t plus 3 over 2t square plus 1/3 t cubed. This guy will come in very important later on in the question. For part 2 itself, okay, what we have is the value of t when it's at instantaneous rest. So basically at instantaneous rest, the velocity is equal to 0. So we get t equals to 2 or t equals to negative 5. Very interesting, this question. Okay, it means this. So the particle, all right, I draw the particle here. The particle will start to move until t equals to 2. It will U-turn, then it will just keep moving. Does it U-turn back again? It doesn't. Okay, so it only turns one time and that's it really. So basically the article goes t equals to 2, it U-turn back, and it will just go on. Okay, it will never come back and U-turn back again. And t equals negative 5 is rejected because time cannot be negative. Okay, part 3, the distance traveled in the second second. Okay, so if you remember what we spoke about, the second second means that I'm looking at the motion from t equals to 1 and t equals to 2. In between t equals to 1 and t equals to 2, does the particle U-turn? It does not. Okay, why it does not? Because it only U-turns at t equals to 2. So between t equals to 1 and t equals to 2, the particle does not make a U-turn itself. So when t equals to 1, I use my displacement equation. Okay, just to write out for you what the displacement equation is, negative this one, negative 10t plus 3 over 2t squared plus 1/3 t cubed. Okay, you sub in, you get your displacement is negative 8 and 1/6 and negative 11 and 1/3. So since it does not U-turn, you just minus away these two values, is 3 and 1/6 meters. So basically, okay, if you were to draw the diagram itself, okay, at t equals to 1, all right, is at negative 8 and 1/6 meters. At t equals to 2 is at negative 11 and 1/3. So the particle at t equals to 1 is at here. Then it continues moving until it reaches negative 11 and 1/3. So this is at t equals to 2 itself. So if you just imagine the particle is moving from t equals to 1, t equals to 2, is moving like this. Here again, it's moving like this. Okay, so all I need to do now to get the distance here that is traveled is I take 11 and 1/3 minus 8 and 1/6, I get 3 and 1/6 meters. That is part 3. Now, part 4 is the total distance traveled in the first 3 seconds. Okay, remember where does it U-turn? It U-turns at t equals to 2 itself. So just let me draw a diagram for you to help you understand this question a bit better. So at t equals to 2 itself, okay, t equals to 2 is at negative 11 and 1/3. So it U-turns one time at t equals to 2 seconds. So this particle is actually moving backwards. So at the start here, it moves, okay, until t equals to 2, it will U-turn. All right. So at t equals to 2, particle starts to U-turn. So down here, okay, is at t equals to 2. And this distance here, okay, at t equals to 2 is negative 11 and 1/3. So the particle actually moves backwards right from the start. Then, okay, at 3 seconds is negative 7.5. So the particle will move, okay, until it continues moving until this point here, where this is t equals to 3. So where is negative 7.5? You can label here negative 7.5. All right. So now, okay, see ya, okay. If I were to highlight this portion here in green, how do I find this value? This value here can be found by taking 11 and 1/3 minus 7.5. So if I take 11 and 1/3 minus 7.5, I get 3 and 5 6. So this portion here is 3 and 5 over sorry, this is wrong. Okay, this portion in green, what am I talking about? This portion here in green is just 7.5 by itself. 7.5. Then the next portion here in red, okay, I don't use red, in blue here, this is the portion whereby I take 11 and 1/3 minus 7.5, I get 3 and 5 over 6. So this portion here is 3 and 5 over 6. Then I use another color. The portion here in the portion here in yellow, okay, is also 3 and 5 over 6. So the total distance that this particle has traveled will be 7.5 plus 3 and 5 6 plus 3 and 5 6. So in total, okay, what you travel is 15 and 16 meters, as shown here.